2.6 we're going to spend about a week on. It is a challenging, it's a challenging unit. It consists of 3 different things. Today is, of the 3 things that are in 2.6, today's the easy day. But one of the things that you need to understand about 2.6 is we're going to start talking about functions and graphs and domains and ranges and things that are probably going to be new to you. Okay, today might not entirely be new to you, but there's going to be some information here that will be important that you need to make sure you know. So today we're talking about our absolute value functions. Now, I know that in the past we have worked with absolute value equations, absolute value expressions. Okay, but we haven't looked at functions and their graphs. Okay, and that's what we're going to be spending a lot of time on over the next week plus. What's again really important is that as you are graphing, you should be using graph paper. If not, you should have a grid that's pre-prepared from the internet somewhere, that kind of thing. Make sure when you submit your homework that your paper is turned on so that the graph comes through. Okay. Now, a couple things that we need to know, but with an example first. So this first example, graph f of x equals the absolute value of 2x minus y, or minus 4, excuse me, and we're going to identify the domain and range. So the problems that you're going to be working on today are going to be like this. And actually the problems that you're going to be working on all through 2.6 are very similar to this as well. One of the main concepts that we're going to be working on is really how to find the domain and range from a graph. And today, I know we've touched on that briefly, we've talked about it a little bit, but today we're really going to start solidifying that idea. And so it's important as we start working through these graphs that we ask questions when you have them, but to be sure that you feel confident that you understand how to find the domain and range from a graph. Now, the first thing you need to know about any absolute value function is what the shape is going to be. So as you go to graph these things, you should already have an idea in mind of what the graph might look like, or at least its general shape. Okay? So the absolute value graph, they're always going to be shaped like a V. Always. Every single time. Some are going to be skinny V's, some are going to be fatter V's, some are going to be upside down V's. And the numbers in the problem will tell you that. So it's always going to have that sharp point at the bottom, or it could have the sharp point at top and it's facing downward. But it's always going to be a V. When you're graphing and you have these problems, if your shape doesn't look like one of these, you've done something wrong. It will always look like that. Okay?
That's because it can go positive and negative.
Yep, and we're going to learn later on in this unit what makes the graph flip over. We're going to learn about when it shifts left or right or up or down, but we're not doing that until after 2.6. Okay. Now, what we're really going to be doing most of the time, and so that's why some of these problems, it's going to seem like you don't have a lot of problems for homework because it takes time to do the graphing. You're going to graph by hand. And so in each one of these problems, you're making a table of values. Okay? Every time. And when you do that, okay, you just have to be careful. And for this reason, technically I could start like this. Like every problem's going to kind of look like that. Remember, there's actually no y in this problem. What is like y here? F of x. So in reality, we could change this and make it, instead of saying y, we could write f of x right there. Okay? I'm not going to get too hung up on the idea of putting a y in the work. Where I am going to have an issue is when we go to do the domain and range. For the range, since there is no y in the problem, when you express the range, I want to see the f of x. Okay, that's the place I'll get particular. But as you work through the problem here, if you want to make a y here, that's fine. if you want to get fancy and you want to say, you know what, I get it, you could make this f of x. Okay? It's up to you when you work through it here. What's not up to you is when you express the range. That, I'm telling you, it needs to be f of x. Okay? So I'm going to switch this back out because I know we're more comfortable when it's a y. Now, when we make our table, you're going to have to come up with a bunch of points. And I know one of the questions that you always want to know is, how many points do I need? And my answer is, you need enough. You need enough points to form that V shape. Okay, and so sometimes you'll figure it out quicker. Sometimes it's going to take you more points. Okay, but it's going to be a little trial and error. So my first question to you is, because I can always pick a value for x, plug it in, and find out what f of x or y is. What value should I always pick for x?
0.
Why?
That is the easiest.
Why? What makes it easy?
No, it's on the x-intercept.
You already have the one.
Olivia, say what you just said.
It cancels out.
It cancels out the x. It makes the math easier, okay? So when I plug 0 in here for x, and I go to find f of x, this cancels this whole term out, okay? So, and if you still aren't feeling comfortable with absolute value, you can actually write the expression out, okay? And I'm plugging 0 in for x, and then I'm just simplifying this, okay? And like Olivia said, this term just drops out as 0. 0 minus 4 is what? Negative 4. Okay, so I have 1 point. Okay, what should the next x value that I try be? 1, right? Because that's the next easiest one. Okay, what should I try after that?
2,
What do you think after that?
3.
Should I always pick 0, 1, 2, 3?
No.
No, I mean, can you? Of course. Okay, now, let's just start with those 4, okay? I want you to go ahead and find the y values, find the f of x values for those other points, and let's try to get a sense of what's going on there. Now, if you feel comfortable that you can you're plugging your 1, 2, and 3 in here, and you're comfortable doing that math in your head, you're welcome to do that. It's pretty simple math. So go ahead and do that. Find the remaining values for that. The other thing you might want to do, so here's a blank grid that I'm going to use in this presentation. If you want to take a picture of that and put it in your notes, put it in your photos, that way you have it rather than having to draw a set of axes every time in your Notability. It's there for you. You're welcome to use it. Now, of course, we already came up with the first one, 0, negative 4. So I'm going to go ahead and plot that, 0, negative 4. Okay, you guys have been working on the other points. And I know Manuel was complaining about so many points. Why do I have to do all those points? Okay, but what happens after you come up with a couple points? What do you start to see? A trend, a pattern, right? So then there's not really math after that. You're just noticing what happens, right? So what happens here? What's 1 going to be? When I plug 1 in, what do I get? Negative 2. Okay, so I've got 1, negative 2. Then what happens? What happens when I plug 2 in?
0.
You get 0. Okay, so what do you think 3 is going to be?
2.
Okay, now before you go there, here's the thing I'm going to warn you. Okay, while that might be true, and it actually does work, since we know that this thing has to be a V, it could be upside or it could be downward facing. It's possible that now at this point I get a point over here and I start making a V going this way, right? Thank you very much. So it could turn here. Okay, we don't know yet. And so we plug 3 in, and of course we get 2. And so it doesn't turn. Okay, so that pattern would still work. Now here's the part where graphing absolute value functions can get a little tricky and can trip you up. Because we have 2 options here. Either this is going to keep going up, and it's like the right side of the V that goes up. Okay, which would mean if I keep picking X's over here, I'm not really gaining anything. I'm just repeating this pattern over and over and over again. Okay? That's one possibility. The other possibility is if this was a downward facing V, maybe over here it's going to start coming back down. And so the trial and error that you're going to have to go through to do these graphs is just that. When does it turn and go the other way? And which other way does it go? So it could either turn down, but if it just keeps going up, then that means it turns somewhere over here and goes up on this side. Okay? So that's the thinking, that's the problem solving, that's the process you have to go through is when does this function make a turn? Because we all know it has to be a V. We don't know if it's upward facing V or a downward facing V yet. We're going to learn about that later on. But in this 2.6 chapter, that's going to be your challenge. Figure out when it makes the turn. Okay? Now, if our math is right, if I were to choose 4 for x, this should be 4, right? Because of our pattern. And we can do a quick check of that. If I plug 4 in, what do I get here? 8 minus 4 is 4. So it just keeps going up. So what should we try next instead of 5? Negative 1. Let's go on the other side. Okay, we've been moving this way. Maybe we should try going this way. Okay, so when I plug negative 1 in here, 2 times negative 1 is what? Negative 2. And the absolute value of that is 2. So 2 minus 4 is negative 2. Okay, so when I plug negative 1 in, it actually goes back around. And if I went to plot that, you'd see that I have a point right there. And so it sort of looks like a check mark now, right? But what we know for sure is that it made a turn. It started going back the other way. It didn't keep going down this way, which that's going to happen to you too. It's going to keep going down this way sometimes. We talked about it going up this way. If this happens and this point ends up being down here, then you just got to keep trying. Maybe I got to go further away from it, or I got to go further away from it that way. That's the point that you're going to get a little frustrated when you can't figure out where the turn is. 2 things are going on if that happens. 1, you're just doing your math wrong. Okay, you're making a silly mistake. Or 2, you haven't picked a point far enough away from where you started. Now, the other thing that I would suggest is maybe take a look at the numbers in the problem. Sometimes the numbers give you a hint, okay, as to where to go. All right, the next part about absolute value is because since it's a V, there is what's called symmetry, bilateral symmetry. You can cut it vertically right down the middle, and it'll be a mirror on each side, okay? So if you notice here, this red point is 1 unit away from the y-axis. This black point is 1 unit away. So over here, I can come up with some other points. This is 2 units away from the y-axis. So there's going to be another point 2 units away from the y-axis. Okay, and the same thing is true here. This one is 1, 2, 3 units away at 2. So if I backed up and went 3 units away that way, I would see that symmetry. Okay, and on this slide, I kind of showed that. Okay, there's that symmetry there. And so you're starting to see that V take shape. Now, from here, you should feel confident, like I know what this V looks like. This is enough. I have enough points. I don't need to do anything else. We can call it good, okay? So that's when I said at the very beginning, you're going to want to know how many points do you need, and my answer is enough. Enough so that you can see the shape. Okay, now we can see the shape, we have to connect the points, right? And that connection is going to look something like that. Point of emphasis. Make sure you have the arrowheads pointing up and or down if it's a downward facing V. So that's kind of how you graph. And it was a lot of trial and error, right? We just picked some values, we plugged them in, and we kind of saw what we got. And that's going to happen to you in your homework as well. It's always got to make a turn somewhere because the shape always has to be a V. There's no other option for an absolute value function. It has to be a V, okay? Or a downward facing V. Now, we've only done sort of part of the problem, Okay. The next part is we have to identify the domain and range. And this is a conceptual thing that is at times challenging. Okay, so I'm going to start by writing D equals with the brace, the left brace, R equals with the left brace. Now, today's the start of learning that visual, conceptual way of determining what the domain and range is. Okay, sometimes one or both could be all real numbers. Okay, sometimes neither will be all real numbers. But I want to give you a concept today that will help you kind of determine that, okay? So here we go. For the domain, and I'm going to explain this here in a second, but write this down. Look for walls. And I know you're saying, what does that mean? And I'm going to explain in a minute. Okay. For the range, look for ceilings or floors. I'll explain in a minute. Just get it down and then we'll talk about it. Now let me explain what this means. Okay? We're looking for naturally occurring walls or naturally occurring ceilings and floors on our graph. Okay, so just to be clear, the reason it's a wall, because walls are vertical, right? Vertical walls. Okay, so we could have a wall here, we could have a wall here, that kind of thing. And it hits the x-axis, so the x values. My question is, so we know this graph goes up and right forever. You know, that's what the angle is. It's not vertical, it's not horizontal. It moves both up and to the right. This one moves both up and to the left. But when we're talking about domain, all we're worried about are walls, which means all we're worried about is a right wall, okay, a right wall somewhere, or a left wall somewhere. So my question to you is this. Is there any wall that naturally occurs with this graph that's going to stop this graph from moving to the right forever?
No.
Okay, so is there a naturally occurring right wall that will stop this graph? Obviously, if I drew something in and we chop the arrowhead off, then we could say, oh, it stopped. But the arrowhead is really important because it tells us it goes on forever. So there's nothing to the right that's stopping the graph. Okay, is there any naturally occurring wall to the left?
No.
No, it's going to go to the left forever. So there's no right wall. There's no left wall. There's no naturally occurring wall. So what does that tell us about the domain?
All real numbers.
All real numbers. It tells us there's no restrictions. It can be anything. There's nothing stopping the graph from moving right forever, and there's nothing stopping the graph from moving left forever. So in this case, the domain is all real numbers. So that's the first concept. The walls always go with the x's. The walls always go with the domain. Okay? That's what's important there. Okay, that's the first part of it. The range are ceilings or floors. So we're looking for, again, a naturally occurring top. Is there anything stopping this graph from going up forever? No, it's going up forever. There's no ceiling. Is there a floor?
Yes.
There is. Okay, there's a naturally occurring floor. There are no y values down here. You're never going to get -8 or -10 for f of x or anything below -4. And let's think about it. What is true about this absolute value? Forget about the numbers in it. What has to be true about what I highlighted in purple? Has to be positive or 0. It has to be 0 or positive. Okay? So, in other words, the smallest value that this could be is -4. Right? Because this, the smallest value this can be is 0. So, in other words, what this equation is telling us is f of x can never be smaller than -4. Because in order for it to be smaller than -4, this thing would have to be negative, which is impossible. Which is why we see this naturally occurring floor. Now, the question is, how do I write an expression that says it can be 4 or what?
Greater.
Bigger. It can be 4 or bigger. So how would we say 4 or bigger in math?
Y is greater than or equal to -4.
Okay, very close. Except There's no y in this problem. Go.
F of x.
F of x. Okay, that's where I'm going to be particular. You're not wrong. Y has to be greater than or equal to -4. But this is Mr. Zukin being picky. Okay. To me, I look at this and I say there's no y in this problem. Okay. Oh, that was not what I want to do.
You can just see it -4. And that's
Now,
what it is.
we're gonna learn how to tell from the equation itself, but for now we're just gonna graph. Okay, so my expression is gonna be for the range f of x greater than or equal to -4, and it can be -4 if for some reason this was an open circle down here.
How can
Then it would be just greater than. For the problems that you're gonna do, that's not gonna happen. Okay, but just understand that could happen later on to more complex problems. Okay, this is what this is saying is f of x or y can be anything greater than or equal to -4. And if you think about it, this is the y's, right? This goes up forever. So the y, the range, can go up forever. Question?
So it's the, like I get the range, but for the domain, so it's just like, can you explain that again?
Sure. There's nothing stopping this graph from moving right forever. And there's nothing stopping this graph from moving left forever. So in other words, there's nothing, if there was something stopping it, or if there was a spot where there were no x values, right? Like for example, when I move along the x-axis, there's always going to be an x value on this graph somewhere, no matter how far out I move. And
Like infinity,
right,
right?
so there is no wall, right? Like it doesn't, you can keep moving on the x forever. You can keep moving to the left forever, meaning there's always going to be an x value on the graph. Okay?
It's just gonna take-
And later on, not in this section so much because, right, like, I mean, our graph is either this or it's upside down. So for absolute value function, I'm just going to be straight with you, the domain is always going to be all real numbers because it can go to the right forever or to the left forever, whether it's facing up or facing down. Where your restrictions are going to come into play with absolute value is right here with the domain, or with the range, with the range. That's where you're going to see a floor or a ceiling, right? If it opens down, then there's going to be a ceiling. If it opens up, there's going to be a floor. Because it has to be a V. That's the thing we all have to understand from the very beginning. It has to be a V. So it either opens up and has a floor, opens down, has a ceiling. Now, when we get into some of the other stuff on Friday and Monday, you can forget general rules. You can throw them out because anything could happen for those, I'll tell you that. Moving forward. That's why today's the easy day. We'll just kind of baby step you into domain and range, and then later it'll get tougher. Okay?
Done.